Okay, welcome. We've got this second of the function tutorials, and we've looked at notation and the domain and range of functions, and in this one we'll look at composition of functions. If you want to head to the other two, there should be links popping up on the screen, but for this one, composition of functions is what we'll look at, and what I'd like you to think about initially is two functions. F of x is x squared plus 2, and h of x equals 5x. Composition of these two functions. Now, if I give you a number and I ask you to first of all put it into f and then take your answer and put it into h, I'm asking you to do a composition of the two functions. I could equally ask you to take the number 3 and go through h first and then go through f and see what happens. So 3, going through f, what we see, square, add 2 is the instruction. 11, now go through h, multiply by 5 is the instruction, there's our answer. And if we go through h first, multiply by 5, and then 15 squared, add 2, 2, 2, 7. There we go. We've used a composition of the two functions. We can compose as many functions as we wish, 2, 3, 4, 5, whatever. We can use a function again, f of f of f, etc. But an important thing to see here is that we get different results, and this often happens. We get different results if we use the function in a certain order. So our notation has to reflect this. This first one, what I am doing is I am doing this. And sometimes written like that. Both are fine. You'll see either at different times. We work from the inside out, so we take the 3, go through f, and then we go through h. So we've got to read it in the correct order. So go through f and then go through h. So in fact this second one, what we were looking at here is f h of x, sorry, not x, let me get that right, 3, or f of h of 3. Either notation is fine, but in both cases go through h first and then go through f. And that's composition of functions. We could look at the algebra for these, and when we're doing this we can leave the x in if we wish. So h of f of x. Now we're going to go through f first, so I'm going to leave the h and I'm going to deal with the f. And this is where you must deal with the instruction and not the letter. So don't be bogged down by letters here, just deal with what the function tells you to do, which is multiply by 5. So whatever appears inside the brackets there for h, we simply multiply by 5. There's no sort of question whether it's x's, h's, a's, b's. We simply multiply by 5. So we have got 5 lots of whatever we see inside here. So 5 lots of it. If we look at this the other way round, and we'll see why these did not give the same answer if we do this. Well, we're going to go through h first, so I'm going to leave f, deal with h, and then once again don't be put off by letters. The instruction, and we've got to keep our eyes on the instruction, is to square and add 2. So we will square and add 2 to whatever we find there. So we square it and then we add 2. And let's square this, 5 squared x squared add 2, and this is why we see two different answers if we use them in different orders. Okay, let's set up another set of functions. Let's choose f of x, x squared, g of x, this time 3x, and I'm going to put a third, h of x equals 1 over x. What about the question f of g of h of 1/2? Well, take a half, go through h, get an answer. 1 divided by a half should give you 2. Take that answer 2, go through g, that should give the answer 6, and then go through f, that should give the answer 36. So that, if we go through h with a half, we get 2, 2 3s are 6, and then on to f, 6 6 is 36, that should give us the answer 36. What about the algebra for that? Well, f of g of h of x. Well, let's not deal with f and g first, we're going to deal with h, and that will give us a 1 over a reciprocal. If we now deal with the g as we work our way through, then 3 times whatever you see in the bracket. So g tells us to do 3 times of that. It doesn't matter about the letters, it's the instruction that's the issue. So 3 times 1 over x. 3 times 1 over x gives us 3 over x. And finally, we go through f, and once again, don't be put off by letters. Make sure that you are looking at the instruction, and f tells us to square. And so we simply need to square 3 3's, x times x, and that is the composition of f, g, h, and that's what we'll finish off with. There we go. What about that as a function? Let me throw one more function, the good old x squared. What about doing f of h? And let's change our letters just a little bit. Doesn't matter, the letters matter not a bit. We're going to put a through h and then through f. There's our first one, it's gone through h, and now we're going to take that particular expression and we are going to put it through f, which simply tells us to square it. So there we go, that's done. We could, if we want, sort that out by multiplying the brackets out, and either's good. What about this as a function? Well, we're going to go through h twice. First time through, we get 10 minus x. The second time through, we're going to get 10 minus whatever we see in here. And if we get rid of that bracket, minus 10 minus minus plus x, and 10 minus 10 is 0. Strangely, you seem to get x, which doesn't seem very exciting at all, in fact, but fact gives us the correct answer, and you'll be able to see what's happening here. So going through h twice, composing a function out of h, have a look just to get your head around this. have a look at h of 3. Take 3 through h and see what you get. You'll get 7, and then take 7 through h again. 10 minus 7, 3. Bizarre but true, what we've got here is what's called a self-inverse function. Make a composition, and what we'll see straight away is we get back where we started. 10 minus 2 is 8, and 10 minus 8 is 2. So composition of this function, interestingly, this is what we call a self-inverse function. Gets us back where we started when we make a composition of it. What you won't see is you won't see that happening with many functions. Certainly you wouldn't see that happening with f. What about that one? f of a. What's that? Well, through once squares it, and again f tells us simply to square, so the instruction to square is what f's about, and there we go. Definitely not self-inverse there, but f of f, and of course we can do any combination of functions we wish, and you'll be glad to know that we're not going to do that, but of course as many functions as we wish to compose. The following tutorial will deal a little bit more with inverse functions, and we'll touch upon self-inverse functions and bring back to us this idea of domain and range.